In this video, we will be doing a proof with a circle and the equidistance theorem and the converse of the equidistance theorem. Those two theorems are down here in red if you need to remind yourself of them. So here we go. Given circle O, P is the midpoint of QE, prove W is equidistant from Q and E. Here's the proof, and we will be writing it on the diagram over here. So P is the midpoint of QE given. QP is congruent to EP, definition of midpoint. So QP and EP are congruent. Next, draw OQ and OE, 2 points determine a line. So here we will draw a segment from O to Q and a segment from O to E, 2 points determine a line. Next, OQ is congruent to OE. All radii of a circle are congruent. So then OQ is congruent to OE. Next, OP is the perpendicular bisector of QE, equidistance theorem. Point O is equidistant from Q and E, and point P is also equidistant from Q and E. Therefore, OP determines the perpendicular bisector of QE. Next, W is equidistant from Q and E, converse of equidistance theorem. You can think of it as if we extend OP, we get to W. You can think of W being along the line OP. You can think of W being collinear with O and P, however you would like to think about it. Then from there, if we were to draw line segments from O to W and from E to W, those would be congruent because, converse of equidistance theorem, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. And that is our proof.